Good morning. Hello.
Good morning, sir.
Yes. Hello. Please.
Yes, sir.
Hello,
Yes,
students. Shall I start?
Yes, sir.
Start and then go. Yes, sir. Today I am going to have the principles of farm machinery, AE12013, right? Tools and building. Tools and building. So, the slide load illa. Principles of farm machinery. This is a very important section for our students because you are going to have 4 years agriculture engineering subject continuously. So in the final year, you have to specialize in a particular subject and you have to do a practical and then you have to develop one machinery. So if any student, those who are interested on that, they can develop machinery. But we have already developed here 14 machinery here, right? And then Mr. Prabharan also did some machinery. So altogether it will come around more than 20 machines. So students actively participated in this machinery designing. So if any student interest on that, please emphasize on this agriculture engineering subjects, particularly in the designing. It will help you in future. Right, theory. Engine definition, history of engine development, engine cycle, 2-stroke engine, 4-stroke engine, gasoline engine and diesel engine. Engine class, engine systems, tillage engineering and tillage implements, seeders, sprayers, harvesters, engine troubles and maintenance, farm accident and their prevention, method of mechanical fastening, attachment and detachment of farm implement. These are the essential sections. Hello. Right. Green right. Okay. Then theory, then practical demonstration of basic engines, spares, power transmission system, a 4-stroke engine and 2-stroke engine, fuel transmission system, a 4-stroke engine and 2-stroke engine, demonstration of two-wheel tractor, hydraulic system and its components, lubrication system and lubricant selection for engines, identification of primary and secondary land preparation implements, demonstration of sprayers, demonstration of seeders and planters, demonstration of ignition system, demonstration of engine tools, water pump. So introduction to workshop and workshop practices. cutting of metal, shaping, twisting, arc welding, gas welding, argon welding, and mechanical fastening. These are the red colored lines. I emphasize on that. So we study on that one carefully. So you can have examination from that also. The next one. So we are going to have these welding practices. So how to start these welding practices? We don't have any prior experience on this chapter. Yes. Hello? Yes, talking Prabharan. Prabha? Hello? A wide range of material. Prabharan talking. Right. Hello? Prabha? Right, I am here. Selection of material. So for welding practices, so any metals that we utilize for any type of work in engineering, so we should understand the particular metal. There are several metals available, but unfortunately, we can't utilize this pure metal for utilization or for any other work. Therefore, we have to do some metal alloys. So, metal alloy. A wide range of material is used in engineering field, and it is important to be aware of the ways in which these are applied and of the properties which make them suitable for this application, design, and fabrication of machineries and tools. So if you want to design a machinery, so you should have a clear idea about these metals and materials. So we think about that first. So physical properties of metals, coefficient of linear expansion, specific heat, density, melting point, thermal conductivity, electrical resistivity. So these are the basic things. So physical properties of metals or materials. So you should know this one, a plastic, nut and bolt, plastic. This one, here you get metal things. Here wooden things. So we can have materials, plastic, wood, and metal. So in welding, we are highly emphasized on metal. So study thoroughly about this metal, right? So next one. Hello, okay. Mechanical properties, you are screen sharing. Mechanical properties of material, hardness. A material which is hard is able to resist wear, scratching, indentation, and machining. Hardness is measured of its ability to cut other materials. So there are some words available, fairly engineering words, wear resistant, right? Removal of material little by little, that is wear. Scratching also, removal of warping or removing or scratching or removal of material. Indentation, so you may have some depression of metal sheet, that is indentation. Machining means, say example, if you want to make gear wheels, that is known as machining, right? So these are important words they have mentioned here. So you must have engineering point of view. You must utilize these engineering words. That is far better for you. Hardness is measured of its ability to cut other material. Brittleness. Brittle material. Brittle means is something damageable. Okay, simply we can say damageable brittleness.
brittleness. Brittle materials will break easily. Say example, china chatti like that. When given a sudden blow, so sudden blow, so the brittle material will break. It is known as fragility. Fragility is the word you must remember. Fragility. Brittle materials cannot be used in pressure line. Say example in machinery, say example pipeline having some oil pressure or fuel pressure. So pressure line cannot be designed based on this material. Then strength. A strong material is able to withstand loads without breaking. That is simply we can say cast iron. So it has around 3 to 4% carbon, the iron. So it can have very good, it can able to withstand the load without breaking. Load may be supplied in tension, compression, shear and resistance. And these are the forces we utilize: tensile force, tension, tensile force, compressive force, shear force, and resistance, rolling resistance. These are the forces. Forces indicated here, forces. So for this different type of forces that is being developed in engine working, so you must understand all those forces and try to keep your machine carefully. Tensile strength, we can say tensile tension, tensile strength. Example, connecting rod. I understand that you know connecting rod that comes from crankshaft and connected with piston, gudgeon pin. I think you know. Compressive strength, connecting rod, compressive strength, because under compression, the force is passing through the connecting rod. Shear strength, example, gudgeon pin, that also shear strength. So the crankshaft is rotating. At the same time, gudgeon pin is connected with a small end bearing of connecting rod. So that is functioning. So you may have some problem. Shear strength. So shear strength is not enough. So gudgeon pin may be damaged. Resistance, example, wooden yoke. Wooden yoke, you know, carriage, the ox is carrying that one. So you may have yoke. What's the meaning of yoke? Or jumping board in swimming. Jumping board. So there's a pressure available. If you have a carriage, so block cart, we can say block cart, carrying a wooden yoke, then yoke does not break. So that's a resistance. That's a resistance. Okay, that's a resistance force. Okay. The next one. Number 5. Mechanical properties of material. Mechanical properties. Toughness, hardness, brittleness, stiffness, malleability, ductility, plasticity, elasticity, plasticity, ductility, malleability, stiffness, brittleness, hardness, toughness. So mechanical properties of material. Properties mean, how do you define properties? Property of material or metal that can be changed. Say example, water, by providing some heat energy, you can have vapor, right? The form is different. Okay, so the property may change, but the character does not change. So you understand character and property. Property may be changed by providing some external force or external pressure can be changed, but character does not change. So that is why I have mentioned all these things: elasticity, plasticity, ductility, malleability, stiffness, brittleness, hardness, toughness. So mechanical properties. Mechanical properties of metal. Now we come to the point of metal. Metal. So material including plastic, wood material, plastic material, and then metals. But here I mentioned here mechanical properties of metal. So metal have different mechanical properties that I mentioned: elasticity, plasticity, brittleness, weldability, machinability, ductility, hardness, stiffness, toughness, malleability, endurance limit, temperature creep, wear resistance, fatigue, and creep. So you understand little, don't worry about this, then you are coming. So next week we are expecting you come to this place. So I have mentioned this one, then you can take it some such a screenshot or anyway, you collect this information better for you, right? Then metal, mechanical properties of metal. Properties of metal. Okay. Properties of material. So I have already told. Then D, hardness, brittleness, strength. So I mentioned 3: hardness, brittleness, strength. And then number D, ductility. Ductility, the ductile material can be reduced in cross section without breaking. Say example, if you have a rubber, you can pull from both ends. So the diameter of the belt may be reduced. That is known as ductility, because during pulling, it withstands to the force with a reduction of diameter. And malleability. So this is a very important character of metals, malleability. A malleable material can be rolled or hammered permanently into a different shape without fracturing. Right? Different shape. Say example, if you want to make some metal sheet, that is known as malleability. The characteristic is coming here, malleable, right? So that particular metal can be converted into plates or corrugated plates or something like that. Okay. Then elasticity, a material which is elastic with a return to its original dimension after being subjected to a load. Say example, some spring in time tiller. Some springs are spelling mistake. Okay, spring. Toughness. A material is tough if it is capable of absorbing a great deal of energy before it fractures. Toughness. So it needs a great deal of energy before it fractures. That is toughness. Then workshop technology. A systematic function, operation, maintenance and repair of farm machinery needs for better machinery management practices. Say example, you take one engine So what are the function of engine? Then a man can operate this engine. And we have to maintain this engine. Sometimes you have any problem or trouble, you have to repair that engine. Right? So I mentioned these four steps. Function, operation, maintenance and repair. Is it correct? Okay? Right. Then metal, iron and steel. Iron and steel, pig iron, cast iron, alloy cast iron, malleable cast iron. These are different type of cast irons are available. So all are iron. So it can be converted as different things. That's all. Ferric. Normally steel, we can have around 2% of carbon nearly. And cast iron may have nearly 4% of carbon. Right? So different. Rough iron is available, that is around 0.5% of carbon matter. Rough iron, mild steel, cast iron, a different thing. But steel comes between rough iron and cast iron. In between, you get steel. Therefore, cast iron have 4% carbon and rough iron have around 0.5% carbon. So in the middle, you get steel around 2%, right around nearly 1.8 to 2% level carbon. So we add carbon for easy manipulation. Easy manipulation. Okay, we take later. Properties and treatment of iron. Brittleness, ductility, elasticity, hardness, malleability, plasticity, roughness, strength, appearance, like that. There are things are available. Heat treatment of metal. Heat treatment. So metal is available, metal plate or metal rod, or you can have any shape. Say example, knife. Knife is available. So the blacksmith can do something, right? So that is known as hardening of metal, softening of metal. So that is one. But in the engineering side, we are here. So we have already mentioned about that annealing, normalizing, hardening, and tempering. What is annealing? Annealing, we have heat treatment is a particular level and control level, and then we are actually having that particular material as a result that can be utilized as for cold working, hot working and cold working. Hot working means you understand that anvil we utilize some hot iron. Cold working means normal atmospheric temperature, such as pressing, bending can be carried out. Pressing and bending can be carried out. The result is a steel having large grains, that is internal molecular level analysis. The result is a steel having large grains. Large grains mean slightly bigger than atom. That is grains in its structure, which is soft, ductile, low strength, and easy shaped by machining, pressing, and bending. A slow rate of cooling is acceptable in this process. So annealing, that is actually we are heating that particular metal for softening metal, for softening of metals. For softening of metals, we have that particular metal that can be utilized, that can be easily handled. That is why we are doing annealing. The second one, normalizing, heat treatment of steel. Heat treatment process is carried out to give the steel its normal structure. gives faster rate of cooling than annealing. So cooling normally after heating, the metal can be put on sand. Or you can. Hello, Prabha. Hi, Prabharan. Prabha. Okay. Right. Normalizing. Normalizing. This gives faster rate of cooling. So faster rate of cooling, we utilize some water that can be utilized for faster rate of cooling than annealing. Annealing normally we put on sand plate, more stronger than annealing. Therefore, normalizing, we are getting little hardening of material, limited level. And then you can have hardening. In contrast to annealing, annealing means softening of metal. So softening of metal by heating is essential for better handling procedure. So hardening means, in contrast, annealing, this heat treatment process is designed to produce a steel that is hard. So hardening, say example, we can have quenching. Quenching means keeping heated metal into water. Steel will vary in hardness depending upon carbon content, right? 0.5 to 3% level, carbon level. Tempering, the heat treatment process is carried out after a steel has been hardened. After tempering, after hardening, you can go to tempering process. Tempering remove some of the hardness, making the steel less brittle and more tough. How do you obtain this one? This is done by reheating and hardened steel to a temperature between 200 to 450 degrees centigrade to bring about the desired structural change. So actually structural change, structural design, right? Structural change is essential for better handling. After tempering, the material is slightly handled, slightly tough, but less brittle and more tough. So the hardness is reasonable. So that can be utilized for some strengthening purposes. These are the 6 things we have. Right. Hardness, brittleness, strength, mechanical properties of material, hardness, brittleness, strength, ductility, malleability, elasticity, toughness, right? Ductility and malleability, elasticity, toughness. A material is tough if it is capable of absorbing a great deal of energy before it fractures. Toughness, tough thing. Okay. The next one, annealing, normalizing, hardening, and tempering. So you understand the differences between these different type of heat treatment of material or metal. Annealing is actually for softening of metal, for work, for our hot working or cold working, particularly cold working operation, we utilize annealing. So annealing means slightly softening the material. Normalizing This is we achieve the normal structure, that is normalizing, but the cooling is very fast, therefore slightly harden the metal, slightly harden. Then third stage, hardening. So hardening is hard material, say example for cutting tool, say example knife, edge of the knife should be hardened, then only it doesn't break at the time of working. Therefore, hardening is important, but that particular thing, steel will vary in hardness depending upon the carbon content. Carbon content is 0.25 to 0.25, starting from 0.25 to 4%. So different percentage of carbon with the steel. So based on this percentage of carbon is an actual indication of its character. So we have to understand that one. Then only that type of things can be utilized for welding, by welding process. By tempering. Tempering means actually intermittent heating or reheating. That's the meaning of tempering. So we are actually at more hardness to the steel, more hardness. So normalize is hardness, hardening, more hardening, then tempering, additional hardening. So hardening is going up. Heat treatment of metal. So during heat treatment, we utilize some carbon particle for a mixture of metal. And then another thing is for treatment, we utilize different type of chemicals. That also we have. Nitriding, cyanide. So we utilize some chemical for accepting or obtaining ideal level of hardness. So chemical treatment, flame hardening, normalizing, hardening, tempering, annealing, nitriding, cyaniding, types, process and applications are available. So there are so many heat treatment processes are being practiced in different factories. So they utilize based on their requirements. Then annealing of metal, sheet metal to be bent by sheet metal, annealing. Annealing is a mild heating, we can say mild steel, mild heating, and then after that, after heating, you can have product that can be utilized for different work, deformable and easily machinable microstructure. Easily machinable microstructure. Right? Easily machinable. Then normalizing means we are little hardening of metal. Say example, connecting rod, okay, connecting rod. So normalizing of metal, intermediate hardening. Heterogeneous microstructure, that is primarily available in the metal, heterogeneous microstructure. So it is not arranged properly, so it is too difficult to handle sometimes. So we have normalizing process, actually heat treatment, then we can easily identify homogeneous microstructure. So homogeneous microstructure is more feasible for hard working or for hot working or cold working, right? That is easy. Heterogeneous microstructure is not so suitable because it is too difficult to have better finishing. That's a problem, right? Then, example, we can have connecting rod. You know connecting rod, and try to identify the connecting rod and understand the metal and its hardness and work and its breakages. There are so many things you can identify from connecting rod. Then you can have some sort of knowledge about this metal. Annealing and normalizing. So normally we have 0.5% of carbon steel, 1% level and 1.5% level. So we can go up to 1.5% level is the maximum for normalizing and annealing. So this is actually soft metal. So that can be utilized for working. And then we have 4% carbon, that is cast iron, very rough, very rough. So this is middle level steel, mild steel. And before that, before 0.5, you can have 0.25% level. You can have another graph like this, that is actually for steel. Steel means very easy to handle, right? That is easy to handle, right? Then come to the next point. Tempering of metals. Tempering is actually we are having metal fairly or considerably high hardening of metal. At the same time, we have nearly high percentage of carbon particle. We heat treat metals, we heat treat metal in an attempt to optimize the mechanical and physical properties, and physical properties for a given application. Most people think of heat treatment as a process for hardening metal. That is wrong, because hardening metal is one of the methods. It doesn't have all methods. That is hardening, one method. Annealing, hardening, another method, right? So, annealing actually softening metal. And other three, right? Normalizing, hardening, tempering, those are actually heat treatments to achieve high hardness of metal in different level. That's all. But only the annealing that can be utilized to obtain soft metal. So soft metal can be used for any type of mechanical operation, right? Cutting, bending, sheet making, like that. There are different type of work. So many heat treatments are applied to soften metal in order to allow metal working operations such as deep drawing, cold forging, and machining. These are the operations. Where increased strength and where resistance. Where means removal of a certain amount of metal at the time of working. That is where, very little amount. Less than 0.001% level. Less than that also. That is where resistance is required. Hardening and tempering tempering treatments are given. Extremely hard steel find application in cutting tools where highly defined edges must be maintained, and heat treatment of these steel is a critical operation. Heat treatment. Hard surfaces with a ductile base material may be developed by heat treatment. So simply you understand this process, heat process. Heating process, you can have it annealing, softening of metal. Then second one, you can say hardening of metal. Then tempering of metal. Right? So little by little you increase the heat allocation or heat. Then you are trying to make new metals. So new metals, mixture of metals. So that is metal alloy. Mixture of metal is normally same alloy, ALLOY, alloy. Alloy is a mixture of metal. Whether it is 2 or 3 or more than 3, that is depends on manufacturer. So for their own work, they can have it. The next one, temperature and time. GST line, okay, don't worry. Austenitizing. That is less heat. Quenching is a water treatment. Strengthening, hardening, tempering. Right? So different classification, something like that. Okay, you study ESK line. Okay. Hardening of metal. Hardening is the process of heating the steel to temperatures sufficient to produce an austenite condition. Austenite condition, depending on the carbon content of steel, followed by rapid cooling at rate fast enough to prevent the transformation to any product basis differ than Martin sites. This cooling type is called quenching process. Quenching means treatment of cold water. That is quenching. Purpose of handling, purpose of hardening. So I took this from book. The main objective of steel hardening process are inducing high hardness and achieving high wear resistance for steels. Hardening is done to all duty carbon steel machine. Parts and almost all machine parts made of ore. Metal alloy, right? Metal alloy, non-ferrous metal alloy is preparation of metal. zinc. Metal alloy. Alloy means a mixture of metal. Metal. Say example. So we mix aluminium with magnesium for making body of aeroplane. So non-ferrous metal and alloys preparation of metal. Alloys preparation. Non-ferrous metal, aluminium, copper, tin, steel. Hot rolling, cold rolling, molding, and casting. These are some basic essential operation with metal. Hot rolling, right? Hot rolling. Cold rolling, the rolls you know, rolls, right? Hot rolling means, so we have to utilize this. We have to work with this metal at the time of heating. So we need heat, right? That is hot rolling. Cold rolling, this is a room temperature, we can do cold rolling. Molding means mold some axis, so molding. Casting, so casting of machines, okay, casting of anything. Bronze, this is bronze. Metal sludge, steel, copper, cast iron, aluminium, and brass. So the non-ferrous metal. Cast iron, there are many types of cast irons available, covering a wide range of mechanical and physical properties. There are many types of cast irons available, covering a wide range of mechanical and physical properties. Steel, cast iron, alloy of iron, and carbon. Carbon content increased to 2% to 4% level. So cast iron you can have 4% level of carbon. So very high hardened material that can be utilized for making cylinders or cylinder head, something like that. Because yes. Grey cast iron, variable cast iron, spheroidal graphite cast irons. So different cast irons are available for different type of job. But anyway, but we study the engine. So engine, where do you get this cast iron? That is available in the engine block, right? Engine block, you get cast iron. So cast iron is can withstand high pressure, and it can't stand with any blow, right? You may have crack. Cast iron, grey cast iron, due to cheap and easily casting. This cast iron is widely used. 3% silicon, 1.5% phosphorus, 0.1% sulfur, 1.5% manganese are available. Grey cast iron. The contents of grey cast irons is different: silicon, phosphorus, sulfur, and magnesium. Manganese Malleable cast iron. Malleable. That is, you can make some sheet, metal sheet, malleable cast iron. This is white iron, casting and free from graphite. Three types are available. White hard cast iron, black hard cast iron, pearlite cast irons. So the white hard cast irons for agricultural machinery design. Black hard cast iron for tensile strength, say example, engine block and connecting rod, something like that. Then pearlite cast iron for high strength, spheroidal graphite cast iron. Spheroid graphite cast iron, it is known as SDI, spheroidal graphite cast iron, or SGIron, and also known as ductile iron and nodular iron, used for making equipment. Tool technology, where we utilize this one. Equipment, plowshare, or axe shear, cultivator, disc shear, and moving shear. Also think about the shin, S-I-N, shin. Shin means the cutting part of any cutting tool and machine tools. Cast iron. You understand this cast iron, carbon steel, right? Cast iron. This is rough iron. Rough iron having the earlier, very old house, our gate, right? Earlier gate. So rough iron, it has around 0.25% of carbon. So you can increase up to 0.5% of carbon as rough iron. So if you have more than 0.5% of carbon, that is mild steel, right? But it is around 4% level, that is cast iron. I think this is known as rough iron. Rough iron, you have 0.25%. Then cast iron, you can have 4% level, and the steel nearly 2% level. Melting point of rough iron, 1500 degree Celsius. Cast iron, 1200 degree Celsius. 1300 to 4400 degree Celsius for steel. Hardness cannot be hardened or tempered. Hardened by hearing and sudden cooling. Can behave window tempered. Okay, leave it, don't worry. Right, come to the point. Copper and its alloy. Hello, student, are you listening? Hello? How many students are listening? Okay. Copper and its alloys. Copper is one of the famous metal we utilize for making wire. Coppers. Aluminium also we utilize for utensils. And then copper, rough pitch copper, phosphorus, deoxidized arsenical copper, brass, zinc and copper mixed alloy brass. So from this you get bronzing. Bronzing is one of the operation of welding. So where we can have zinc and copper as an alloy that can be utilized for filler material. 70 to 30% brass, 60 to 40% brass. High tensile brass, copper, zinc, aluminium, magnesium, tin and ferric. Bronze, copper, tin, zinc and phosphorus. Phosphor bronze, gunmetal, copper 88%, tin 10%, zinc 2%, up to 9%. 5% of PB lead, certain 2%, 10%, copper 88%. So that is gunmetal. Gunmetal is very dangerous. Okay. But anyway, we produce this one, not an important element. Aluminium and its alloy. Aluminium and its alloy. It is formed in different shape and size, which could be utilized based on requirement. Different shape and size, aluminium utensils that are available in different size, different shape, different capacity, and for used. It is formed a different shape and size which could be utilized based on the carbon. Sheet, tube, you can make sheet, aluminium sheet, aluminium tube, aluminium strip, wire, plate, forging, bar, casting and foil thickness. Foil thickness is 0.2 to 0.005 millimeter. Other material, lead, corrosive resistance, lead, corrosive resistance, platinum, melting point 1770 degree centigrade. Platinum, silver, highest thermal and electrical conductivity, gold, percentage of nickel, gold alloy is used. So normally we do not utilize gold because it's very expensive. Therefore we can have nickel. It's an additional metal that to make alloys. Tungsten's melting point 3650 degrees centigrade. Tungsten is being utilized for filament bulbs, electric bulb filament. Alloy with silver and copper. Asbestos, fibrous structure containing various substances including magnesia and silica. Right? Asbestos. So 86 students are getting reduced. Alloy properties. Aluminium alloys, magnesium alloys, zinc alloys. So these are the very fundamental things. But if you don't have this type of knowledge, it is rather difficult to identify some metal for welding. So simply you can't weld because if you don't identify the metal after welding, it will break after 2 months or 1 month. Sometimes suddenly it may break. Therefore, you should understand all metals, aluminium alloy, magnesium alloys, and zinc alloys. Lightweight. Aluminium, simply we understand lightweight, structural material, resistant to corrosion, maintain strength at high temperature. Maintain strength at high temperature. Magnesium alloys, lightweight and structural material, lightest of the commodity used alloys, lightest of the commonly used alloy, magnesium alloy, high tensile strength, high tensile yield strength. Then zinc alloy, one of the heaviest metal, zinc alloy, very heaviest metal, heavy metal, excellent corrosion resistance, provides better impact strength, So this is aluminium, magnesium and zinc alloy, more general. So we can utilize this one effectively. Metal processing, heat process, forging, riveting, soldering, brazing, punching, drilling, adhesive bonding, welding, gas welding and arc welding. So metal processing, metal processing based on heat process. Forging means there is an anvil, it's a black thing that is available, on which we put hot iron for making knife or something like that. That is forging operation. Riveting, you know this door riveting, you understand. Soldering we can have PV, that is lead that can be utilized for soldering, say example, some baldier, some buckets, they can do the soldering. Okay. Brazing is normally utilized. Brazing we utilize copper and zinc. So that type of operation can be utilized only for bicycle, because you can have that bicycle bar which brakes. Then you can do only the brazing, not gas welding or arc welding. Only brazing that can be done. Punching is also essential factor. The next class I will show all these things and its pictures. What is punching? Punching is the removal of say certain amount of metal from a metal sheet. Say example, for making some fan or something like that. Or you can have the plate of string coppers, something like that. Punching. Drilling. So drill hole. So making some drill hole by utilization of drill machine. It can remove a certain amount of material and then you can have some holes. Making holes, that is drilling. Adhesive bonding, that is a chemical that can be utilized for bonding. Say some metals can't do anything, so bonding can be done. Even metal. Material bonding is available, but metal bonding is rare. But anyway, we can do this metal. Hello, student. Hello. Gas welding and arc welding. Gas welding, normally we utilize acetylene gas with oxygen. Arc welding, we utilize current as an heat energy source and we utilize that one so we can study later. Right, forging. Right, you understand forging. Forging, making some tools. Say example, removal of onion removal, right? Or wheat removal, weeds removal. Or forging, we need sometime mamati you can utilize, right? There are some words available. Forging. Then you identify the person, how forging. Next one, riveting. Riveting, I think you are more familiar with this one. Rivet head, rivet pin, and rivet end that is available in your rooms. You can see at the same time you can ask somebody how does it work, right? That is essential because this is actually riveting means fastening a metal, fastening of metal. Soldering. Soldering, we can have this computer unit, soldering, right? Electric soldering. So we utilize uh, uh, lead alloy as filler. The filler. This is one line is available. PV, lead, right? Lead. Then you can have fusion at the tip of this lead, so that can be utilized to build this. Okay, like that solder. Bracing. Bracing is very very famous during this period, and then normally for making some copper utensils, say example water pump spare parts, right? Pump spare parts, so that can be utilized bracing, right? Bracing. Bracing. Bracing is known as bronzing, same meaning, bronzing. Punching, you see punching, so punch, making some holes, like punching, right? Scrap, workpiece, blanking, sheet metal piece, punch. Punch is some sort of machine. We utilize here punching, right? Punching, prabhar, okay, punching, and then drilling, drilling. So here also removal of some metals for making holes. Say example, nut and bolts are utilized for this hole. No? That is the purpose of drilling. Adhesive bonding, master bond, we utilize that one for our work. Adhesive bonding. This is actually gum, something like metal gum. We can say metal gum, right? Adhesive bonding. And then gas welding. Gas welding we utilize acetylene and oxygen, and base metal, there you have welding torch. This is known as welding torch. You can hold it, right? There are two one screw is available to control this gas supply. We can control. So at the same time, filler rod is available. Filler rod is the rod that can be utilized or used as filling metals. Right, but the temperature is very high. Fuel, propane and air flame, propane and oxygen flame, hydrogen and oxygen flame, acetylene and oxygen flame. So very high, 3,500 to 6,332 degrees Fahrenheit. Regulate. Standard setup for oxyacetylene welding, arc welding. So we can have some more. One more time. Forging. You understand this forging. So some students have very rare chance to observe this type of work because they are studied bio student and they have very less experience on this one, and they don't want this type of knowledge at the time of taking advanced examination. Therefore, they don't notice anything. But nowadays, you understand, once you go outside, you must observe what are the activities going on in the factory or any workshop or anywhere else. You try to understand what they are doing and how do they handle this type of material, hot material, cold material, heavy material, and metal alloy. There are so many things are available. So you must understand everything for handling this type of work. Otherwise, you may have problem, right? Therefore, you study. This is known as anvil. This part is a metal part is available. No, that is anvil, on which we utilize this for iron and break it. Okay, then you see the person holding hand gloves. This is extremely very high quality and it's not flammable. At the same time, you can have 100% precaution from external sources. Then you can have next one, riveting. Then next one, soldering. Next one, bracing. Next one, punching. Next one, drilling. Next one, adhesive bonding. So this is your section. Yes, these parts are available in your syllabus. So you study. So that is your part. You have to study. Right. Then 34. So what is the time, please? I don't have a handphone to see my time. So what is the time, please, now? Hello, students. What's the time? Right. Gas welding, oxyacetylene welding. You can have it. Oxygen is a large one, acetylene is a small one, right? So here the main point is there are two things available, pressure gauge. One pressure gauge indicates pressure of the cylinder. Second one is indicate the pressure on hose line, right? Then here also same thing at the handling torch or handling point. You have pressure relief valve, acetylene and oxygen, both you have. That is welding torch, because we utilize some heat and light. So we say this is welding torch. So the amount of gas released from the cylinder can be measured here at the point of handling torch. So you can control this one. We have two things. We are controlling acetylene, at the same time we are controlling oxygen. So after starting this tip, or after starting this blowtorch, you can adjust this flame to blue color. Standard setup of oxyacetylene welding. Right, 86 students. Arc welding. Arc welding is a welding process that is used to join metal to metal by using electricity to create enough heat to melt metal, and the melted metals, when cooled, result in a binding of the metal. So spare parts is important. Welding machine is available. AC/DC machine or anything, anyway, electricity. So you can have the amount of amperage allow for this machine working. So normally we have 70 to 120 amperage machine. So normally we use 80 ampere level for welding, right? So there are two cables. One is ground cable, then electrode cable. There are two cables. Those electrode cable will go to electrode holder, which holding electrode. The bead is available. Bead means liquid drops of metal. That is bead. Liquid drop of metal. So ground cable can be utilized for connecting the circuits, right? Electric circuit. So that is ground clamp, ground cable. So connected. Now the welding machine is working. So the ground is important. Electrode cable, sharp welding, and then 35, arc welding and gas welding. Gas welding, the main point is gas welding, pressure regulators. Pressure regulators are extremely important because you can't play with the life. If you have less knowledge about this gas, don't open this cylinder. Don't touch it. That is very essential. Don't lose your life. Don't touch cylinder. And then arc welding, we utilize electricity. So you must have some pre-planning to avoid accidents. And then you can cut off this current line passing through body. So you can have electrode holder with gloves. And then you can have very nice shoes. Okay? Then for eye protection, you can have Google or face shield you can utilize. Electrode welding machine, electrode holder, feed, arc, ground clamp, ground cable, electrode holder. Then gas welding, welding torch. Here we utilize welding torch. Here we utilize electrode holder. So different things. You can compare these two things and understand the basic function of gas welding and arc welding. Both are basically different because energy source is different. Electricity is a energy source for arc welding. This acetylene gas, the energy source for gas welding, where we utilize oxygen for making blue flame. Blue flame, the hottest flame with less light. But here they mentioned yellow color, that is slightly, that is for their own work, okay. Here come to the point, pressure regulator. One pressure meter indicate the pressure of the cylinder. The second one indicate the pressure of relief valve, the pressure. So both you can have it in two different things. And then gas supply to welding power source. This is our workpiece or base metal where we are going to have our operation. So at the time of operation, we utilize, we are enclosing this circuit, enclosing this system. Then electrode cold, gas, you different, no? Tungsten electrode, arc welding, workpiece, electrode holder, shielding gas. Shielding gas means actually we have some flux. Flux is available. Chemical, this is our electrode. In the middle you get steel rod available. That is known as filler. And outside you have flux. Flux, flux. It's a chemical. That chemical can be utilized to prevent oxidation. So we are heating the metal to 1000 degrees centigrade. So by heating 1000 degrees centigrade, it is dangerous because of oxidation. So we have to prevent it. Otherwise you may have problem, right? Bad welding. Therefore, that flux is a chemical that can cover this area, that surface or weld surface to prevent oxidation. And then finally, that flux can change as slag, S-L-A-G, slag. It's a black portion that is already covered the welded surface. So the slag should be removed by shipping hammer. There's a special hammer available that can be utilized to remove the slag, because slag is acidic character, so it should be removed. After utilization, we remove this slag to prevent oxidation. Slag is preventing oxidation of metal, of heated metal. At the same time, after operation, the slag may cause corrosiveness because of its acidity. So you remove that one. Suddenly you have to remove that slag. Slag is a deposition of flux. Flux. Flux, deposition of flux. After welding, you can have black coating. That black coating is known as flux. Burned flux. That is equal to slag. Slag can be removed by using chipping hammer. There's a simple hammer. Hammer is available that can be utilized for removing slag. So arc is available. Arc means the length of spark is known as arc. Right? So we study later one by one. But now we go. How many students are available here? Only 85 students. So 47, 47, 52 students absent. 52 students are absent. Right? Only 85 students are present at the moment. So soldering, bracing and welding. This knowledge is extremely important to all people, not only the students, normal people. They can have this type of work because you can have your own workshop and then you can earn money. So if you have this interest on this, you study little and then you open your welding unit in your house and do something, and you can have another known person for your helping. And this is one of the good practice for our agriculture students. They can have very nice welding unit. They can earn lot. So please take some sort of interest on this subject and study well. Soldering, bracing, welding. Right? Main tools. Hammer, power hammer, hot chisel, taps and dies, chisel, pulley and belt, axle, file, drill, grinding machine, vise, workbench, rubber, workbench, electric drill, breast drill, center punch, scraper, screwdriver, socket wrench and ratchets. So these are the normal tools we utilize frequently. Therefore I have mentioned this. So you should understand hammer. Metal hammer is available, different type of hammers are available, mallet available, wooden hammer, so available. Power hammer also available. It works under getting source from electricity, power hammer. Hot chisel can be utilized for removing a little amount of metal. So hot chisel, that means at the time of heating, so this chisel can be utilized. Hot chisel, cold chisel, both are available. Taps and dies. Tap means internal thread cutting. Taps and dies, internal and external thread cutting. No? For example, making nut and bolt. Available nut, available bolt, available. Nut has thread internally and bolt has thread externally. So both can be fitted. There's the taps and dies. There are two types of devices that can be utilized to make threads, internal and external threads. So that is the way this machine is available in our laboratory, you can see. Then chisel, you know that. Then pulley and belt, you know. Axle is a SD plate, you know SD. very hard plate. It can be utilized for cutting metals. Then file. So file that can be utilized. Different type of files are available. So many type of files available. The next class I will show everything. But now today time is not enough because different slide. Then drill means making holes, drill bits. Grinding machine. So shaping machine, grinding machine, okay, you know that. Sharpening tools. Then vice, not vice chancellor, vice means it's a device that can hold any metal for working. Say example, vice is being utilized for making holding. Then next one you can have it. Vice. Okay, workbench. There's a special bench prepared for workshop. So that is essential workbench, maybe wooden table, heavy table that can be utilized for work. Someday we may have metal bench for some work, metal work. So wooden metal workbench are available. Bench means metal work. Electric drill we have already told. Electric drill. The drill needs electricity for working. Breast drill means so that is actually hand drill. That is actually hand drill. Center punch is extremely essential for drilling because drill is comparatively powerful. So it is too difficult to identify the point on which we are going to have work. Therefore, center punch is available. We identify the particular point and then make some mark. That is center punch. That can be utilized for marking. Then you can utilize drill. Scraper also we can have, say example, paper, no? Sandpaper like this, scraper. Something like sandpaper or scraper. Screwdriver, we have different types of screwdriver, mainly 3 types. Positive type, negative type, and Allen screw. So only basically we have 3. Minor screwdriver, plus screwdriver, and Allen key. Allen key that is being utilized for removal of some sockets, right? Socket wrench. And ratchet. Ratchet is a fairly advanced spanner, and it can measure the force we applied on that particular work. That's the only advantage. And then we have another advantage is ratchet can be utilized in both directions. So 2 advantages. So this is very essential because no one knows ratchet. They don't understand what is it. And we can give it to your practical. So you must write down something about ratchet, like that. That is a practical oriented tool. Then you go next slide. Hammer, chisel, and then pulley and belt. We utilize this one. and you can calculate this one, the length of pulley, length of belt and everything. And also C is known as idler. C is known as idler, IDLER. That can be utilized for tightening belts. Power hammer. Power hammer is very dangerous because we can have a systematic shape of same type of material. Say example, for making this screwdriver, minor screwdriver, so we give a certain force to the tip of the screwdriver. So same type of force we have to give and same amount of force we have to give. So this power hammer is utilized for industry to have a certain amount of force. The force level can be adjusted. Steps and dies. Those are dies outside. This die means killing. So me allanavani me throat allanavani die. That is die. So you can see simply this round one, that is die, that can be utilized for making thread internal, external thread. That is external thread. Then here we have something. This is steps. That is internal thread. So thread forming operation is entirely different. So no one can do it carefully because it needs a certain level of experience, which type is more useful and what type of steps we have to utilize at the time of starting. There are so many points available. If you do this one systematically, you can have 100% good results. Otherwise, you may have problem with this, the taps used. So sometimes you can't put nuts. Okay. Hacksaw is available. Hacksaw is the blade is being utilized for cutting metals. That is hacksaw. Then come to the point number 40. 940. File 2, file, F-I-L-E, different type of files are available. So metal work, you can't cut it quickly. You can't reduce quickly the size of the metal. So you need a certain amount of time for making a little work. Therefore, you have to do systematically, correctly, and without making injury to your hand. So little by little, you remove these metals. So we need different type of files that is mentioned here. Round file, half round, you see cross section is half. That's the meaning of this. Cross section is half round file. Square file, this is the cross section. Round file, cross section. And the space we have, they are given for making thread. Okay. Flat file, you know that. Triangle file. Okay. So like that you can have it. Types of drills, you can have it. Different type of drills. This is a drill bit. drill bit that can be removed. This is a breast drill, right? Breast drill, hand drill, breast drill, right? Electric drill, different models and everything. Sometimes some meter can measure. Okay, easy to loading and uploading and that. Right, next one. This is your screen sharing. Okay. This is what do you call this one? This is called grinding machine. Grinding machine can be utilized for sharpening metal, shaping, right? Shaping and sharpening. So we can utilize this grinding machine. Then today we have 37 students are absent. Screwdriver and Allen key. Allen key is available here. Right, different type this one. There are different type of Allen key. Right, anyway, minus, plus. Right, view this different. 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 19, 22. Right, 14. Up to 14 you can go. Therefore, we can have 13 to 14 spanner for push bicycle. So you better to have in your house 13 and 14. Sometime 15 and 16 you can have it. So we need 1 or 2 or 3 spanners for your bicycle repairing, right? So you have to repair your own bicycle. Don't go anywhere. So then only you can understand the mechanism of this, and also you can have some knowledge about this and how to design. So we are actually teaching to you machinery mainly for designing. So you grab one mechanism and then define, and then you remove. Based on that mechanism, you have to design one machinery. And for fabrication means making, you need knowledge of these tools and welding and so on. So that is why we are teaching our students this one. It's a very fundamental thing. So nowadays people are highly interested in having vehicles. So you need this knowledge, 100%. Knowledge is extremely essential. Right, then next one. Vise, workbench, scraper, center punch, making some spot. Vise, this is vise. You can keep anything and lock it. So this is workbench, right? Scraper is available. So this is a sandpaper, something like that. This is metal scraper that can be utilized for different work. Very heavy metal. So highly durable scraper, So you can use it, but less expensive. You can buy this. So this is multi-work tools. So you can have in your house. There are so many works you can run. You can use it as a screwdriver. You can pull your soil. You can dig it. So you can have. You can polish your bowl, or you can have your water tank cleaning. And sometimes you may have this type of like a screwdriver. There are so many work you can do by having this one. I think this is actually around 500 rupees, less than 500 rupees. So every student should have in your house. Then you can have some motivation. how to attach this machinery, and how to design new machines, how to develop Sri Lanka, how to develop your family first, how to identify a good job, personal, private job. So these are the things we have to do, right? Files, teeth and tools. Files, flat file, hand file, square file, round file, half round file, okay, 3 square file, pillar file, mill file, rasp bar file, body file. Then this is file type. Then teeth. Teeth is different. Single cut. But I couldn't put this figure anyway. Single cut. Only one side cutting. Right? Double cut, you can have double cut in one side. Then rough type. Bastard type. So the bastard type that can be utilized for scraping potato like that. Okay, anyway, we go next slide. Time I don't know. Right, flat file, crossing file, different files, square files, middle cut file, sitting file, and everything you can have. Hand file, half round file, area harassment, crochet file, triangular file, raspa cut file. There are so many files available. Right, here you have teeth, the file teeth, right, file teeth, rough type, right, bastard type, second cut. Second cut means double cut, right, smooth, red smooth, right. This is single cut. This is known as single cut. Single cut file that can be utilized for different job. So that is good, right? But normally we can have 2 cuts, right? This type of file we buy, right? Double cut, single, second cut, no, double cut. Second cut, some teachers they put second cut, but this is normally used second cut. No, normally we say double cut, single cut, double cut, right? Safety in farm machinery, power, safety and care. Power, safety and care. Safety in the workshop, mechanical and other accident, safety device, electrical accident, driving a machine, flat and V-belt driving, gear driving, chain driving, power of belt, wear and lubrication, gravity force. So you must have some accident prevention later. Right, next one, see the accident prevention. You understand how accident, this accident, okay, accident danger, right, danger, right, come to the point. Metal cutting, rake and clearance, flat chisel. So I need another 10 minutes and finish it. So file, drill, turning, boring, sharp, shaping, painting, finishing, milling. These are the operation. These are the operation you have to do. Right? The next one. I need only 10 minutes, please. Right? Please wait. Checking and measurements of surfaces. Surface relationship, the accuracy. Test to accuracy, flatness, squareness, parallelism, roundness, concentricity, angle measurement, vernier protector, length measurement, ruler, caliper, micrometer, vernier caliper. Like this you have to study. The bench and flats, bench, wise, hammer, blow delivered, files, and use of file, types of cut, chisel and chip. Shipping hammer. This is shipping hammer I have already mentioned. Center punch, scraping, drifting. Okay. Then making out, drilling and screwing. Angle plate, V-block, parallel shapes, spirit level, dividers, scribing, block, breast drill, ratchet drill, electric drill, clamping, drill holding, locating, drilling, reamers and reaming, taper pin, taps and dies, thread cutting. Introduction to lathe machine. Lathe and its functions, parts of the lathe machine, driving and feeding, turning and centers, preparation of work, parallel turning chuck, 3U and 4U, setting up, boring, parting up of metal cut, thread cut. Chuck work, method of taper turning, taper trimming, taper gauge, screw cutting, determination of gears, pitch and lead, cutting a thread, locating tool, marking lathe, chasing our dial, internal thread, tapping in at lathe. Okay, right. Metal joint, mechanical fastener, soldering, bracing, welding, adhesive bonding. We have to study. Mechanical fasteners, we have so many mechanical fasteners. Mechanical fasteners are available. And then fasteners, so different type of nuts and bolter, washer and rivets and everything. Okay, standardization of fasteners. Okay, then soldering. What is soldering? I have mentioned, no? The soldering. Number 1, fastening. Mechanical fasteners. Second one, soldering. This is alloy, metal alloys. So the third one, bronzing and bracing. Bronzing, welding, arc welding and gas welding, adhesive bonding. Then merit of joining metal. What type of joining metal? Okay. Thank you very much. Thank you. Finish. Hello. Thank you very much.
Thank you, sir.
So I am going to stop. Thank you.
Thank you.